4.2 Translations of the graphs of the sine and cosine functions. In the last lesson, we discussed changing the amplitude and the period of sine and cosine functions. And in this lesson, we're going to learn about shifts. A horizontal shift that will move the graph either to the left or the right on the x-axis is called a phase shift. Instead of the sine and cosine curve starting on the x-axis at 0 degrees or 0 radians, the graph will start to the left or to the right. You can look at the equation to find what the phase shift is. So, given the equation, and here we have it down here, y is equal to a sine of b, which is what we had earlier, but we've added this minus d inside the parentheses. So, connected to the x in parentheses, whatever is added or subtracted to that value or that angle is going to give us the phase shift. And the same thing with the cosine graph. Now, it's backwards from what you would just assume. If you have a plus d, it's going to shift the curve to the left. Minus d is going to shift the curve to the right. So it's going to, the phase shift is going to be the value that's added or subtracted to the angle. It would either be theta or x in the sine equation, or the sine or cosine equation. So let's graph this over one period. Y is equal to sine of x minus pi over 2. So in this equation, we don't have an amplitude change, we don't have a period change, all we have is a phase shift. So let's mark up the graph. I'm going to mark it up. Alright, I have our graph marked up, and let's think about what the regular or the parent sine function looks like. We know that sine starts at 0 degrees or 0 radians. So all we've done is we've shifted our graph over pi over 2, and since this is negative, it's going to shift to the right. So instead of starting at 0, we're going to start our graph at pi over 2. So our sine graph starts at 0 at pi over 2, and then it does what it normally would do. We go to the next quarter, and it's going to go up to 1, and then it goes back down to 0, then it goes to -1, and up to 0. So we still have 5 points or 4 sections on our graph. It's just shifted to the right by pi over 2. Alright. In this next graph, we have y is equal to 3 cosine of x plus pi over 4. So the amplitude in this graph is 3. That's what this is. There's not a change in the period. Remember, the period would be in front of this angle. And then there is a phase shift of pi over 4. Now, since this is plus, the phase shift is going to go to the left, pi over 4. Alright, so I'm going to mark up the graph. Alright, so I put marks on our graph, and the reason why I put these marks on the graph is because we have to have a mark, we have to have the 4 or the 5 key points. Well, there's no change to our period, so it hasn't stretched or it hasn't compressed. So each mark still needs to be pi over 2 spaces apart. Normally we would have a mark at 0, then pi over 2, then pi, 3 pi over 2, and 2 pi. That's pi over 2 spaces apart. So if I start at negative pi over 4, if I add, let me do it over here. So I have negative pi over 4, that's my first mark. And then if I have negative pi over 4 and I add pi over 2, well, that's plus pi over 2, which would be the same thing as 2 pi over 4. That would be at a positive pi over 4. That's my next mark. Let me circle these. Okay, so we start at negative pi over 4. Then the first mark is at positive pi over 4. Then the next mark, I'm going to add another pi over 2. So pi over 4 plus pi over 2, which is 2 pi over 4. That would be 3 pi over 4. And then if I add pi over 2 again, that would be 5 pi over 4, and then another one would be 7 pi over 4. All right, so those are my marks. Let me draw my graph. This is cosine, so we know that cosine normally starts at 0, at positive 1 on the y-axis. All right, so if this is, let me put back in, I didn't put these. So if this is 1 and this is negative 1. Oh, nope, we don't need 1 and negative 1. We need 3. The amplitude is 3. Okay, so let me put in some extra marks in here. Okay, so if we say that's 1, this is 2, we're going to go up to 3. And down to negative 3. Okay, so if our cosine graph normally starts up at 1, it's now going to start up at 3. And then at our next mark, which is at pi over 4, it's going to go down to 0. And then at 3 pi over 4, it goes down to negative 3. And then at 5 pi over 4, it goes back up to 0. And at 7 pi over 4, it goes up to 3. All right, so this is what our graph would look like. And that's our cosine curve with the translations that we have here. Now, a phase shift is not the only kind of shift that can happen. We can have a vertical shift, which means it moves the graph either up or down on the y-axis. And the equation that will show us that looks like this. Y is equal to c plus a sine of bx minus d. All right, so we know that a is the amplitude, b changes our period, d is our phase shift, and now c is our vertical shift. And the same thing with the cosine graph. Now, the c value is what you would think it is. Plus is going to move our graph up, and minus is going to move it down. So let's look at this cosine graph. All right, let's talk about the different possible translations or transformations that we could have. Our amplitude is 2. We see that we do have a change in our period. So remember the way that we figure out what our new period is we take our normal period, which is 2 pi, and we divide it by b, which is whatever's in front of the angle, so divided by 3. So now our new period is 2 pi over 3. Okay, so to determine what our key points or our quarters are going to be, we're going to take this and divide it by 4. All right, so I'm going to do that over here on the left. So if I have 2 pi over 3 and I divide it by 4, I multiply by 1/4. I have to multiply by the reciprocal. Okay, so that would give me 2 pi over 6, which is actually, no, not over 6, sorry, over 12, which is actually pi over 6. So that means that our quarters, of course, we start at 0, then our first mark is going to be at pi over 6. Then if I add pi over 6 to pi over 6, I get 2 pi over 6, which would reduce to pi over 3. And then 2 pi over 6 plus another pi over 6 would be 3 pi over 6, which would reduce to pi over 2. All right, so we had 1 pi over 6, 2 pi over 6, this was 3 pi over 6, so then the next one would be 4 pi over 6, which would reduce to 2 pi over 3, which we said was our complete period, 2 pi over 3. So that's where our marks are going to be, or our quarters, our key points for our graph. Okay, luckily we don't have a phase shift, so we're going to start at 0 and just go up pi over 6 for every mark. And then we have, we also have a reflection, so it's going to reflect. And we have a vertical shift of 3. Vertical shift of 3. All right, I'm going to clean this up a little bit. Let's see. All right, I cleaned it up a little bit and I put marks on the graph. Now let's plot the graph. So we know that it's reflected over the x-axis, and it's shifted up. It's got a vertical shift of 3, and it's a positive 3. So that means instead of our x-axis being at 0, it's going to be like we would just have an imaginary x-axis here at 3. Okay, and then this is cosine. So we know that our cosine graph normally starts at the highest point. On our parent graph, cosine starts at 1. So since it's reflected, it would start at -1, but since our graph is shifted up 3 spaces, and it has an amplitude of 2, we're going to go from our imaginary x-axis here at 3, and we're going to go down 2 spaces. So our graph is going to start at +1. And then cosine would normally go to 0, and so we're going to go up to 0 instead of down to 0, which in this case is 3. And then we're going to go 2 spaces higher up, so we're going to go up to 5 and put our point. Then we go back to our imaginary 0, which is at 3. Then we would end up back down at 1. All right, and this is what our cosine curve looks like with these changes or these modifications. I know that this is kind of tricky to understand, so if you wanted to sketch or do in highlighter what the regular cosine graph or the parent function would look like first, and then make the changes to it, you could do that. We know that, of course, for our regular cosine graph, these points would be pi over 2, pi, 3 pi over 2, and 2 pi. And then cosine would start at 1, and then it would go to 0, -1, 0, +1. Okay, so this is what the parent function would look like. So if we think about the changes that were made to that parent function, instead of just going up and down 1, here it goes, you know, here's 4, here's 2, so it's a difference of 2. We go up 2 spaces, 1, 2, and we go down 2 spaces, 1, 2. So we have that amplitude of 2. Our period, that's where those marks come in, pi over 6, pi over 3, pi over 2, 2 pi over 3. We did that with our quarters. It's flipped upside down because it's reflected over the x-axis, and we see that. And then it had a vertical shift of 3. So instead of this curve going back and forth over, or up and down over the x-axis at 0, it's doing that at 3. So you can see all the changes that were made to the parent function. All right, we have one more. Okay, so again, we'll start with the amplitude. The amplitude here is 2. The period is our normal period, which is 2 pi divided by b. And our b here is 4. So our period is going to be pi over 2. Okay, so everything is going to happen in pi over 2 spaces. Now, to get how far apart each mark is going to be, we take pi over 2 and we, so the key points, or let me call it quarters, it takes up less room. Okay, so our quarters are going to, we take our pi over 2 and divide it by 4, which would be like multiplying by 1/4. So the quarters are going to be pi over 8 spaces apart, okay? But I'm not going to mark out the quarters yet because we have a phase shift. The phase shift would be, this says plus pi, so our phase shift is actually going to be to the left pi spaces. So the phase shift is negative pi spaces. So that means that's where we're going to start. Instead of starting at 0, we're going to start at negative pi. And then we also have a vertical shift of -1. There's no reflection. Okay, our vertical shift is -1. All right, now let's figure out where our marks are going to be. So if our first mark is at pi, a negative pi, we need to add pi over 8 to negative pi. All right, let me do it down here since I have some space down here. Okay, so if we start our first, let me mark these out like this. Let's say our first, second, because we need 5 of them, third, fourth, and fifth. Okay, so our first mark is at negative pi, and then remember that pi is the same, would be the same as negative 8 pi over 8. So if I add pi over 8 to it, I'm going to get negative 7 pi over 8. Then if I add pi over 8, that's going to be negative 6 pi over 8, which would reduce to 3 pi over 4. Then negative 5 pi over 8. And then negative 4 pi over 8, which would be pi over 2. And we said that our period is pi over 2. That's how long it's going to take for a complete period to happen. Well, from negative pi to negative pi over 2 would be pi over 2. Okay, I'm going to mark those on our graph. All right, so I marked up the graph and I had to modify it a little bit because we need our spaces to be spaced correctly apart. And normally each one of these marks on the x-axis in a parent function is pi over 2 spaces apart. But we have one period happening in pi over 2 spaces. So if I started here, then I would have to fit everything in this one little space here, and we wouldn't be able to see it or draw it. So this is what our graph now looks like. So let's plot our points. We know that, first of all, we're dealing with the sine function, and the sine function normally starts at 0 degrees or 0 radians. Well, our phase shift means that our x-axis, or our imaginary x-axis, now starts at -1. So instead of starting or putting our first mark at 0, we're going to put it at -1. And our first mark goes at negative pi. And then our sine graph goes up, and since we don't have a reflection, we know that it's not, it's still going to go up. But our amplitude is 2, so that means we're going to go up 2 spaces. So at negative pi over 7, we're going to go up 2 spaces to +1. and then we go back down to normally what would normally be 0, but in this case it's -1. Then we go down 2 spaces to -3. And then we go back up to -1, and that completes 1 full period. And that's what our sine graph looks like.